Hello dear students, welcome back to my lesson. On today's lesson, we will continue to solving the questions which is related with the full kinematic equation at constant angular acceleration. In a previous lesson, as you know, we stopped here, question 7 in chapter review. This is very good question, be careful, okay? So it has been brought in the ministry exam many times. The question says, a drill starts from rest. Be careful, please. What do you mean by start from rest? If you see the start from rest, which means that omega initial is 0. Okay? And after 3.2 seconds, this is time interval. The time interval is given 3.2 seconds of the constant angular acceleration. The drill turns at a rate of 2,628 rad per second. So, which means that the drill reaches to the final angular speed, which is equal to 2,628 rad per second. Okay? Find the drill's angular acceleration. Okay? What's unknown? A. Find the angular acceleration. B. Determine the angle through which the drill rotates during the period. Angle or angular displacement. Okay? Okay. To find the angular acceleration, because in this question, the angular displacement is not given for the first for branch A, so that is why we have to use this equation. Angular acceleration is equal to omega final minus omega initial divided by t. Replace omega final was given. This is speeding up from 0 to this number. This is speeding up. For the speeding up, the angular acceleration is positive. 2,628 minus 0 divided by 3.2. Angular acceleration is equal to 821. 821, sorry. Alpha is equal to 821.25 rad per second square. So this is the angular acceleration for the drill in this question. Branch B, what is unknown? The angle through which the drill rotates during this period. To find the angle theta, so we have to use this equation, 1 over 2 omega initial omega final times delta t. So you can replace. Do we have omega initial? Yes, was given. Start from rest. Final 2,628 times delta t also was given is equal to 3.2, which is equal to theta 4,204 rad. Okay, so if you convert to rev, sometimes maybe the multiple choices given in the rev, so that is why you have to convert to rev. It depends. Okay, divided by 2 pi, which is equal to theta in rev is equal to 669.4 revolutions. Okay. This is question 7 from chapter review. Question 28. Also, this question is very important. It has been brought in the Wizari exam many times. Okay, and also I expect to bring another time in the Wizari exam. Question 28. But before solving the question 28, I would like to tell you some important notes about this question. If an object starts rotating from rest, then stops. Start rotating from rest, after that stops. The first time omega initial is 0. Why? Because the object started from rest. Okay? After that stops. So for the second time, omega final in the second time is equal to 0. Okay? But omega initial in the second case is equal to omega final of the first case. Okay? How? Now I'm gonna explain in detail. If you have about time in this notes, now I'm gonna explain more and in detail. Okay. For example, if you have an object, the object at first start rotating from rest, which is omega initial 0. After 5 seconds or 10 seconds, the object reaches its maximum. For example, omega final, assume that 5 rad per second. Okay? Then after a while or after a few seconds, the solid sphere of the object stop rotating or stop it. Omega final is equal to 0. Now, in this case, we have two cases. Okay? Speeding up, slowing down. What is the first case? Is speeding up. The second case is slowing down. Okay? So, for the first case, omega initial 0 during speeding up or during walking, omega initial 0, but omega final 5 rad per second, for example. But in the second case, slowing down, omega final in this first case, omega final first case is equal to omega initial in the second case. So, which means that the final angular speed during the speeding up is equal to the initial angular speed during the slowing down. Okay? So this note is very important, be careful. So the question says, the top within a washer goes into its spin cycle starting from rest. Okay? As you can see, starting from rest. What do you mean by starting from rest? It means that the top initial angular speed is 0. Okay? And reaching an angular speed 11 pi rad, which is omega final 11 pi rad per second. This is speeding up from 0 to 11 pi. What is this? This is speeding up. Okay? In 8 seconds. So this speeding up is occurred in 8 seconds. Delta T in the case of speeding up is 8 seconds. So it means that this top in this washer started from rest from 0 rad per second to 11 pi rad per second. So it takes 8 seconds. Okay? So at this point, the lid is opened. The lid of the top is opened. When the lid is opened, because of the safety switch turns off, okay, the washer, so the top slows to rest in 12 seconds. Okay? What do I mean by that? It means that after reaching this angular speed, the top, because of the lid is opened, okay, the door and the lid of the top is opened because of the safety, the turning of the wheel will stop, and in that case, the omega final in the first case, okay, omega final of the first case is equal to omega initial in the second case, which is equal to 11 pi rad per second. So what do you mean by that? It means that this 11 pi rad is omega final for the case of the speeding up, and also this 11 pi rad is omega final for the second case of slowing down. Okay? So what is omega initial in the second case? 11 pi. Slows to what? To rest. What do you mean by to rest? It means that omega final second case is equal to what? 0. From 11 pi rad, okay? Let's remove this, and I'm going to write down omega initial was 11 pi rad per second. Okay, from 11 pi to 0, this is slowing down. During stopping from 11 pi to 0. So how long does it take? 12 seconds. Delta T is 12 seconds. Okay? Through how many revolutions does the top turn and assume the constant angular acceleration while the machine is starting and stopping at constant what? Angular acceleration. So that is why we have to think about the four kinematic equations. Okay? During the speeding up, as I told you, omega initial 0, omega final 11 pi rad per second, t1 during speeding up 8 seconds, theta is unknown. During slowing down, because in this question we have two parts, slowing down and speeding up. Okay. In the second case, during the slowing down, omega initial is equal to 11, the same omega final in the first case, and omega final 0 because the question says the top is slows to rest. Okay. Delta t was given, T2 was given during slowing down, 12 seconds. Delta theta is unknown. So we have to solve this question like that. For the first case, during walking or during speeding up, how can you determine delta theta or theta 1? Theta 1 is equal to 1 over 2 omega initial omega final times t. Okay. Theta is unknown, 1 over 2. Omega initial in the first case during working, when we say during working, which means that speeding up. Okay. Omega initial 0, final 11 pi times 8 seconds. Theta 1 is equal to 44 pi rad, which is equal to, if you convert to rev, is equal divided by 2 pi is equal to 22 rev. If the question asks us to find the number of revolution during the speeding up or during the working, you have to select this value. Okay? Please be careful. Pay attention in this question. In this question, what is unknown? The total revolution for the entire system during stopping and during working. Look, through how many revolutions does the top turn? Okay, the question doesn't say through how many revolutions the top does turn during slowing down or stopping. Okay, assume constant angular acceleration while the machine is starting and stopping. But if the question says through how many revolutions the top turn in the first 8 seconds. In the first 8 seconds, how many revolutions do we have? 22 revolutions. Or during speeding up, how many revolutions do we have? 22 revolutions. Okay, this is the number of revolutions during speeding up. During slowing down, okay, during slowing down, theta 2 is equal to what? Is equal to 1 over 2 omega initial omega final delta t during speed slowing down. Okay, 1 over 2 omega initial was not given in this question, but indirectly the omega initial was given. Omega initial in the case of slowing down has the same value omega initial in the case of speeding up. Okay, so that is why omega initial is equal to 11 pi plus 0 times 12 seconds. Okay, so theta 2 is equal to what? Is equal to 55, sorry, is equal to 66 pi rad. Okay, if you convert to rev divided by 2 pi, okay, theta 2 is equal to 33 revolutions. So this is during what? During stopping or slowing down. If the question says through how many revolutions does the top turning during stopping, only during stopping. If the question asks us to find the number of revolution during stopping, or if the question says through how many revolutions does the top turn in 12 seconds. In 12 seconds, the top is turned 33 rev or 66 pi rad. Okay, but the question, because in the question it doesn't indicate to find the number of revolution during speeding up or during slowing down, so that is why we have to find the number of revolutions for all the times, for the entire machine, that speeding up and slowing down. So that is why theta total is unknown. Is equal to what? Theta 1, theta 2. Theta total is equal to 22. We found it for the first case during speeding up. Okay, so 33 rev. So this is during slowing down. Okay, but theta total is equal to 55 rad per 55 rev. Okay, 22 plus 33, which is equal to 55 rev of the time. Okay. So about this question, for example, A 22 rev, B 33 rev, C 55 rev, D all of them. Okay, if they bring this question in the wizard, and if the question says, through how many revolutions does the top turn? Through how many revolutions does the top turn without indicating during speeding up or during slowing down? In that case, we have to find the total angular speed or total revolutions, which is equal to what? 55 revolutions. In how many seconds? At first, we have 8 seconds during slow speeding up and slowing down 12 seconds. It takes what? It takes 20 seconds. Okay? But if the question says, through how many revolutions does the top turning during 8 seconds? During 8 seconds, which means that theta 1, we found it is equal to 22 rev. Okay? So this is in 8 seconds, which is speeding up. Okay, so but if the question says, through how many revolutions does the top turn during slowing down or in 12 seconds? In 12 seconds, you have to select 33 revolutions. Okay, in 12 seconds, which is the case of slowing down. Okay, so be careful. This question is a very good question, and it has been brought in the Mizari exam, and also it will be expected to bring again. Okay. Question 31. This question says, okay, a coin with a diameter 2.4 centimeter is dropped onto a horizontal surface. As you can see in this figure, okay, the diameter of the coin is given 2.4 centimeter, drop it onto horizontal surface. This is horizontal surface, okay? So the coin starts out with an initial angular speed 18 rad per second. Okay, what is this? Omega initial is given is equal to 18 rad per second, okay? And rolls on a straight line without slipping. What do you mean by without slipping? It means that this surface is a rough surface, not smooth, okay? If the rotation slows with an angular acceleration of a magnitude 1.2 rad per second square, what is this value? 1.9 rad per second square. If you see the units, because the units of this number is rad per second squares, that is why this value is angular acceleration, which is equal to 1.9 rad per second square. How did you know this is alpha? This is angular acceleration by the units. How far does the coin roll before coming to rest? How far? What do you mean by how far? Which means that delta x or delta s is unknown. In that case, delta x has the same value of delta S, arc length. More arc length is equal to more displacement by the coin. Okay. For example, for one complete cycle, okay, if the coin starts rotating from here, one complete cycle, okay, it takes, for example, this arc length, which is equal to delta x. Okay, so that is why delta x and delta s is directly proportional. More arc length, more distance covered by the coin. Okay. Before coming to rest, what do you mean by coming to rest? Coming to rest, which means that omega final is 0. Okay, so omega initial 18, omega final 0. This is speeding up or slowing down? This is slowing down, absolutely. Which one is bigger? Omega initial bigger than omega final. So that is why alpha, it should be what? Negative, please. The alpha is what? Negative. Why angular acceleration is negative? Because the coin is coming to rest, slowing down. In the case of slowing down, angular acceleration has negative sign. Okay. So in this question, you have to make a plan. Okay. The plan of this question, we have to find delta x, which is equal to delta s, and we know that delta s is equal to theta times r. Why? Because as we studied before, theta angular displacement is equal to what? Arc length divided by radius. Arc length is equal to what? Theta times r. In this question, arc length is equal to delta x. Okay, so that is why we need what? We have to find what? Delta s. This is the unknown of the question, because the question says how far, which means that this displacement, okay, which is equal to what? Delta x. Delta x and delta s in this case is equal, okay, or is the same thing. But in this question, do we have theta? No, we don't have theta. The theta is not given in this question. So that is why we have to find theta. Do we have radius? Actually, the radius also not given directly, but the diameter is given. Can we convert diameter to radius? Yeah, of course. But at first, I would like to find the radius, okay, which is equal to d divided by 2 and 2.4 divided by 2, which is equal to 1.2 centimeter, and convert to meter because it's not allowed to solving with centimeter. That is why we have to convert to meter times 10 power negative 2. What is this? This is radius. But in this question, we don't have angular displacement, delta theta. We have to find delta theta, okay? Delta theta is equal to what? Because the time is not given in this question. That is why we have to use this equation from four kinematic equations. Omega final square is equal to omega initial square 2 alpha delta theta. Okay? Do we have omega final? Yes. 0. Omega initial 18 square 2 times alpha was given negative 1.9. Why negative? Because slowing down. Times delta theta is unknown. If you rearrange the equation, square 18 and take to the other side, and rearranging according to math basic, theta is equal to 85.3 rad. 85.3 rad. This is the angular displacement. So after that, we can replace into this equation to find delta S, which is equal to theta times r. Do we have theta? We didn't have at first, but we found it is equal to 85.3 times the radius also was not given, but instead of radius the diameter was given, okay, and the diameter is equal to twice of the radius, and radius is equal to the half of diameter, which is equal to 1.2 times 10 power negative 2. So delta S, or how far the coin rolled before coming to rest. The coin has 1.0236 meter. So this coin is covered this distance when it is rolling on the rough surface. Okay, so this is question 3, and it is very good question. Please be careful. Okay. The last question in chapter review, as I told you, I'm going to solve all questions in the chapter review which is related with this topic. Okay, so I'm going to solve, and I solved mostly of the questions that is related with the kinematic equation at constant angular acceleration. The last question, question 32. A mass attached to a 50 centimeter string starts from rest. What do I mean by start from rest? Omega initial is 0. And a mass attached to 50 centimeter string start from rest, which means that this is a string. Okay, so this is the mass. Okay, so this rope, the distance of the rope, which is equal to the radius. Okay, so which means that R is equal to 50 centimeter and equal to 0.5 meter. Okay, rotating in a circular path. Okay, exactly 40 times in 1 minute. 40 times in 1 minute. The time is given 1 minute, which is equal to 60 seconds. Theta in revolution is given 40 times. Okay, so we have to convert this theta in rev to rad. Theta in rad is equal to 2 pi times 40 theta rad, which is equal to 80 pi rad. Okay, before reaching the final angular speed. What is the angular speed of the mass after 1 minute? Omega final. Omega final is unknown in this question. So which equation can be used? Because we don't have angular acceleration, that is why we have to use this equation. When does this equation can be used? When angular acceleration is not given and not required to find it. Okay, so theta is equal to what? 1/2 omega initial omega final times delta t. Replace theta was given in rev, but we converted to rad. We have to solve the question with rad for angular displacement. 80 pi 1/2 omega initial 0 final is unknown. Delta t was given. Delta t 60 second. Okay, this is cancelled with this one 30. Okay, and omega final, which is equal to 8.38 rad per second. Okay, so in this question, if we will study in the next section, inshallah. In this question, if the tangential speed is unknown, to find the tangential speed is equal to angular speed times r. After we studying the tangential speed, I'm going to remind you about this question. So do we have omega? Yeah, we found it, 8.38 times. Do we have radius? Yes, 0.5 vt tangential speed, which is equal to 4.90 meter per second. Okay, so that is all about the section 1. Now I'm gonna solve the questions of the section review, section 1. Okay, sorry. Convert the following angles in degree to radian. 35 degree, we have to convert to rad. Okay, theta in rad, as I told you, is equal to 2 pi over 360, or you can say pi over 180 is the same. Time is 35, which is equal to this number. Okay, in the second case, the same thing, theta rad is equal to pi over 80. Is it possible to multiply angle in degree to 2 pi over 360 or 2 pi over 180 is the same thing? Why? Because this 2 will cancel with the 360 is equal to 1 over 180. Okay, so a mosquito lands on a phonograph record 5 centimeters from the recorder center. Okay, so this is R, which is equal to 0.05 meter. If the record turns clockwise, turn is what? Clockwise. So that is why theta should be negative. Why? Because in the clockwise direction, the theta is negative. The mosquito travels along their arc length. So this is arc length, which is equal to 0.05 meter. In the case when R is equal to delta S, theta is equal to how many rad? Is equal to 1 rad. When does the angular displacement or theta is equal to 1 rad? In the case when arc length is equal to the radius. Okay, so which is equal to 57.3 in degree or negative 0.159 rev. If you see in the Wizari exam, the multiple choices, this is A, this is B, this is C. Which one is correct? D is correct, all of them. Okay, but in the first case was given in rad, in this degree, and this is rev, because the theta has 3 scales we can represent in all scales, but for the solving question we have to use rad. When an object moves on a circular path for complete or the entire circle, what do you mean by entire circle? So when an object starts rotating here, what is this? This is entire circle. For the entire circle, one complete cycle, how many revolutions do we have? 1 revolutions. How many rads do we have? 2 pi rad. How many theta in degree do we have? 360 degree. This is for entire complete cycle or 1 complete cycle or full cycle. Okay, but for complete 3/4 of the circular path or circle, theta is equal to 0.75 rev. Okay, which is equal to, okay, this is 3/4 rev, which is equal to 270 degree and 4.71 rad. But for complete half cycle, okay, this is half cycle. For half cycle, how many rev do we have? 0.5 revolution, half revolutions. How many degrees do we have? 180 degree. How many rads do we have? Pi rads. Okay. So for complete quarter of the circular path, what do we mean by quarter of the circular path? Which is equal to, if you have a circle, only this part. 1/4 revolutions, which is equal to 90 degree and 1.75 rad. A bicycle, very good question, be careful please. It has been brought many times in the Wizari exam. So this note is related with the question 3. For every 3 questions, I wrote some notes about the tricky questions, okay? Question 3, a bicyclist rides along a circular track, okay? If the bicyclist travels around exactly half the track, what do you mean by half the track? It means that theta is given is equal to 1/2 revolutions, which is equal to pi rad. Okay, but if the question says the bicyclist travel around exactly 3/4 of the circular path, the theta is equal to 3/4 rev and is equal to 4.71 rad. In the case when the question says if the bicyclist travel around exactly 1/4 of the circle, which means that the theta is equal to 1/4 rev and is equal to 1.57 rad. Okay, but because in this question says exactly half of the track, theta is equal to what? Pi rad. In 10 second time, 10 second, okay. So what is the average angular speed? Average angular speed. To find the average angular speed, you have to use this equation. Only this equation can be used to find the average angular speed. This is different with the four kinematic equations. To find the average angular speed, you have to use only this equation. But if you see in the question start from rest, stop, constant angular acceleration, which means that you have to use the four kinematic equations at constant angular acceleration. Okay, so in this case you can replace theta pi divided by 10 is equal to pi over 10 second. Pi over 10 rad per second. Okay, so you can open the pi is equal to 0.314 rad per second. Question 4, physics in action. Find the angular acceleration. Find what? Angular acceleration of a spinning amusement park ride that initially travels at 0.5 rad per second. What is this? This is omega initial. The accelerates to 0. This is omega final. From 0.5 to 0.6. This is speeding up or slowing down? This is speeding up. Which one is bigger? Omega final or omega initial? Omega final is bigger. So which means that alpha is positive or negative? Alpha is positive. But alpha is what? Is positive. The last question in section review, section 1, physics in action. What is the instantaneous angular speed? Instantaneous angular speed of a spinning amusement park. Okay, a ride is that accelerates from 0.5 rads per second at constant angular acceleration of 0.2 rad per second square for 1 second. Okay, what is the instantaneous angular speed of the spinning amusement park ride? That accelerates from 0.5, which means that omega initial 0.5 rad per second and omega final is unknown. What is unknown in this question? Omega final. At constant angular acceleration, alpha is 0.2 rad per second square in 1 second. Okay, because alpha is equal to omega final minus omega initial over t, cross multiply omega final, which is equal to omega initial alpha t, replace omega initial was given, alpha also was given, time is 1, omega final, which is equal to 0.7 rad per second. Okay, so that is all for today, and we finished the section 1, and I recommend you to solve the all ministerial question which is related with the section 1. Okay, because already after the end of each section I solved it and I wrote many Wizari exam for the students. Okay, so you can solve all the questions which is related with the section 1. Thank you for listening and hope you benefited from my lesson.